It looks like here with example 10, first thing I see is minimize. So this time we're going to look for a low value. So we're going to minimize this equation subject to, wow, we've got a lot of inequalities going on here. So let's start out just like before. So this first one right here, if I take away the y value, or the y variable, you'll get x equals 10. And then if I take away the x variable, you'll get y equals 10. Okay, that's good. Next one, 3x plus y is greater than or equal to 12. Okay, first of all, take away the y, and then so you get 3x equals 12 divided by 3, so x equals 4. Next thing, wipe away all the x's, and you get y equals 12. Just find those intercepts. Now negative 2x plus 3y is greater than or equal to 3. Alright, so let's take away the y's. Imagine those are all gone. So you'll get x to equal a negative 3/2. And then next time around, if I take away all the x's instead, so imagine that all gone, then I'll get y, divide both sides by 3, equals 1. Okay, so those are my 3 intercepts. Let's come over here and find ourselves a graph. Wow, we got all the way, let's go by maybe 2's this time. So we got some 12 going on here. Okay, that might help out just a little bit. So first of all, let's graph this first one. I'll do it in purple. It's going from 10 to 10. So 2, 4, 6, 8, 10. And when I'm drawing this, all these are solid lines. I'm going to stay in quadrant 1 again because we have that point up there, that value says I need both of these to be stayed between, in the first quadrant, both x and y greater than 0. And I want to be able to add 2 values and stay smaller than 10. So again, we're going to be coming down towards the origin. So that way I can pick any 2 values in there and still stay smaller than 10. Okay, the next one, we're going to go from 4 on the x-axis up to 12 on the y-axis with my intercepts. So that coming down right there. And it says specifically that I want to be able to add these 2 values and get larger than 12. So I'm thinking to the right of this one, but let's test just in case. How about we test this point 4, 4 right there? That's t, 4, 4. So is 3 times 4 plus 4 greater than 12? That'll give me 16, so definitely for sure. So with this one, we're going to be shading this direction with that line. Okay, so right now my overlapped region is kind of like this lower triangle right in here. If I stop, that would be my overlapped region. We're going to keep going on just a little bit more. We have another line. Okay, that one has a y-intercept of 1. So it's kind of hanging down right there. Has an intersection of an x-intercept of 1.5, so maybe right about there. And it's just that tiny little line right there. And it says I want to be able to sum up these 2 values and make it larger than 3. So let's test. Let's test, how about 2, 2? Negative 2 times 2 plus 3 times 2. Is it greater than or equal to 3? So it's negative 4 plus, let's see, 6. Is that greater than or equal to 3? Well, that gives us 2, so it's not. On this one, all I'm going to do is come right down through there. You know what, I'm looking at that going, I did something wrong, didn't I? I graphed a very incorrect x-intercept. Let's go back and fix this just for 2 seconds, because we want to get this correct. I don't have the correct x-intercept in there. Okay, so if we go back and now actually, okay, y-intercept of 1, and x-intercept of, I'm used to all of them being positive, so watch out for that. There we go. And then it's coming up through there. That's looking a lot better. So there's that next line. Okay. And again, let's test, how about we test 0, 0? So, because that would be on this lower side of that. So coming up there is negative 2 times 0 plus 3 times 0 greater than or equal to 3. Well, 0 and 0 is definitely not larger than 3, so I want to shade above this line. So we're going to come up this direction. All right, that was a good thought. I mean, a good thing to look for and to double check, because what I did at that point when I stopped just for 2 seconds, I was like, wait. There's no region on that graph technically where the purple, green, and orange all overlap. So it's like, how am I going to get a solution region? So then I realized, you know what? I graphed the wrong x-intercept. So right in here, we have a triangle that looks like that's where I have all three colors overlapping each other. So it's going to be right in here. And so I have corner points at all three of these intersections. So let's go up here and let's find our corner points. Make a table of them as we get them. Looks like this time none of them are going to be really simple or easy. We're actually going to have to pair them up and go 2 by 2. So let's start with this bottom left one. It's at the intersection of that orange line. So that orange line is negative 2x plus 3y equals 3. And then what it's intersecting with is the green line. Okay, well, the green line is 3x plus y is equal to 12. All right, going up there, just to do some math, what we want to do is try to eliminate one of the variables. If I multiply this second equation by, let's say, negative 3, let's see if we can do this all at once. So a negative 2x minus 9x would be a negative 11x. Is that okay if you all are kind of following with me here? So negative 2, I'm going to multiply and subtract at the same time. So negative 2 minus 9 is negative 11. 3y minus 3y is 0. And then over here on the right, it's going to be 3 minus 36. And 3 minus a 36 is a negative 33. So dividing this out, you'll get an x value of 3. Yeah, that looks kind of over here at 3, so that's pretty good. Now to get my y value, I'll get negative 2 times that x plus 3y is equal to 3, just plugging it into that top equation. So negative 6, oops, hold on. Negative 6 plus 3y is equal to 3. Add my 6 over, we get 9. Divided by 3 is 3. So we have a corner point of 3, 3. And that looks pretty legit for being right down there in the bottom left. Okay, let me erase some of this and let's get on to the next corner point. Okay, if we want to try the next corner point for being kind of like this right one right there, it's at the intersection of the orange line, or the red line, whatever you want to call it, and the purple line. So we have negative 2x plus 3y is equal to 3, and we're going to intersect that one with the purple line. And the purple one is x plus y is equal to 10. Alright, so just kind of like what we did just before, maybe if we want to do elimination, maybe we can do this all at once. So I multiplied this second equation by 2, then I can eliminate the x's. So negative 2x plus 2x is 0. 3y plus 2y is 5y. And 3 plus 10, 2 times 10, so 3 plus 2 times 10 is 23. So it doesn't look like we're going to get a very pretty answer here, but 23/5. We can work with that. I'm going to go to the purple one to plug in the next part. So it says my x value plus that y value of 23/5 has got to equal 10. So x is really 10 minus 23/5. Okay, so that's 50 over 5 minus 23 over 5. So x is 27/5. All right, there's another corner point. So 27/5, that's basically 5 2/5 for my x value. And then my y value is going to be 4 3/5. Let's double check on that graph. Does that look about, see, 2, 4, 5, not quite 6. That looks good. And then maybe a little bit higher than what it should be, but it's kind of, at least it's better in there than saying if it was like 10, 12. That would be a little problem. All right, let's go next and let's find that upper left corner point. And that upper left corner point looks like it's happening at the intersection of the green line. So 3x plus y equals 12 with the purple line. And that purple line was the x plus y is equal to 10. All right, since the y's are the exact same in magnitude, both 1 and 1, let's just subtract. So 3 minus 1 is 2x, y minus y is 0, and 12 minus 10 is 2. So this gives us an x value of 1. That's not too bad whatsoever. And then the second part is, let's go to the second line to help us out. What can you add to 1 to get 10? Obviously, y has got to be 9. So our last corner point is going to be the point 1, 9. Okay, let's go up to our cost or our C equation, and it says C is going to equal 10 times my x value plus 15 times my y value. So let's get all those plugged in there. I might go back and just kind of, since I'm going to go 10 and 15 times these guys, I might go back and just write that as then the 27/5, just so I can reduce my fractions. And then 15 times, what we say, that was 23/5. And then C is equal to 10 times 1 and 15 times 9. Okay. Well, if we go up there and just basically plug in our values, 30 plus 45 is going to give us 75 here. And if you choose to use your calculator or whatnot, let's see, that would be 20 times, or 5 into 10 is 2, so 2 times 27 and 3 times 23 will give us a 123 value, a value of 123. And then 10 plus 9 times 15 give us 145. Okay, well, we want to minimize this time, so we want to take 2 seconds, slow down and minimize. And the minimum value is obviously coming from this top one again. So we're going to have a minimum value of 75 coming at the point 33. If it asks for us the maximum one, we would say the max is going to happen of 145 will happen at the point 19. Simple as that. Okay. Well, let's just do one more and we'll call this lesson finished.